Color Sixes, I have a problem and I need your help to solve it. As I was putting together your math lesson for next week, I kind of stumbled on a little mystery and I kind of need your help to solve it. So hopefully you guys can work with me to work it out. So there's this problem that is in the homework, and it is this weird looking shape. It has 4 sides, but it doesn't have anything parallel or anything equal. It's not a square. It's not a trapezoid. It's not a rhombus. I can't figure out what it is, okay? But this shape has 3 angles that are known and 1 angle that's not known. And I need to figure out what that missing angle is so that I can teach it to you for this week. So I know how to find a missing angle in a triangle because I know that the sum of the angles in a triangle is 180 degrees. So I'm trying to figure out, I can't remember, and I can't figure it out any other way, is like, how do I figure out what is the sum of the angles in a quadrilateral, a 4-sided shape? It's not a square. It's not a rectangle. It's not a parallelogram. It's just 4 randomness shapes. Here's the picture of what it looks like. So I've got to figure out how to find that 4th angle before our math groups so that I can explain it to you. So hopefully you can help me crack the case of the missing angle. But I need to think. So I actually found a bunch of origami paper, and I think I'm going to try and do a little bit of origami because it kind of gets my hands busy, and sometimes that helps me think and solve problems. So I'll see you in a bit.
3 hours later.
Hey, grade 6s, I have a bit of an update. So I started folding my paper, my origami paper, which is a square, for the crane that I'm going to make. And one of the things you do with a crane is you start with this thing called a bird base, and you have to fold the paper diagonally twice. So even just on my first fold, I realized when I fold this paper diagonally, I get a triangle. And then I unfold, like that kind of triggered something, and then I unfolded it and I see this nice crease line, and I was like, oh, holy, this square is 2 triangles. And suddenly I have a theory. I think I know how to solve the problem of the missing angle in time to be able to teach you guys what you need to know this week about finding missing angles in quadrilaterals and exploring angles inside quadrilaterals. So if I have a square, which is a quadrilateral, a very, very specific kind of quadrilateral, and I fold it in half or cut it in half, I can see this square is actually 2 triangles. And that, I think, is going to give me all the information I need to solve the problem and crack the case of the missing angle. But let's try it out with more than just squares. Let's see if it works with some other quadrilaterals. So I'm going to grab some paper and some scissors and get to work, but I'll show you what I'm doing.
The next day.
Hey there, update. I finished my crane. It's cute. I like it. It helped me think, and I got some really good ideas. So I just want to go over some of the cool things that I discovered with my origami today because it has helped me solve this problem. So I realized when I was folding origami paper to make my bird base that a square is really just 2 triangles. And each of these triangles is identical to each other. Actually, when you put them right on top of each other, they're exactly the same. Now, each triangle, I know as a rule, the sum of the 3 angles in a triangle equals 180 degrees. So if I add together this triangle plus this triangle, I get a total of 360 degrees. And I can say, well, maybe then the total of all 4 angles, the sum of all 4 angles in a quadrilateral is 360 degrees. But this is a square, and a square is a really particular kind of quadrilateral, so I have to try it out with a couple different kinds. I can check my math on the square. I can check to make sure because I know each of the 4 angles in a square is a right angle, and right angles measure 90 degrees. 4 times 90 equals 360. So I know that my theory of having a square split in half to be two triangles. Each one, the sum of the angles is 180 degrees. When you put them together, you can say that the sum of the angles in a square is 360 degrees. That's true. That checks out. I verified it. So I decided to try with a rectangle because a square is a lot like a rectangle. It has two pairs of parallel sides, just like a rectangle does. And it has four right angles, just like a rectangle does. But a square has all four sides the same length. And a rectangle only has to have two sides the same length and the opposite two sides the same length. So I thought it would be interesting to try and see if the same thing worked. And as you can see here, it does work. When I cut a rectangle in half, I get two triangles. They're identical. And I can say the sum of the angles in this triangle is 180 degrees. The sum of the angles in this triangle is 180 degrees. So when I put it all back together again, I end up with the sum of the angles in the rectangle being 180 degrees, 360 degrees, sorry, because 180 plus 180. And I can check that again because of these four right angles. They're 90 degrees, and 4 times 90 is 360. So I thought, okay, well, actually squares are really particular, and rectangles are actually kind of pretty specific as well. So I wanted to try it with a different kind of quadrilateral that didn't have right angles, because maybe this magic only works when there's right angles in the shape. So I tried with a parallelogram. So a parallelogram is a lot like a rectangle and a square, except it's a little tilted. So you can see I still have these two pairs of parallel lines. So that actually, my rectangle and my square are both parallelograms. They're just quite specific. A rectangle is a parallelogram with four right angles, and a square is a parallelogram with four right angles and four sides of equal length. So anyways, as you can see, if we do the same thing and cut our parallelogram on a diagonal line, it does make two, again, identical triangles. As you can see there, they're identical. And even though there's no 90-degree angle in my parallelogram, I still have two triangles. Each triangle has a sum of 180 degrees when you add up all three angles. And so when I put them together, I can say that even though I don't have four right angles, the sum of the angles in my parallelogram is 360 because I know each one of these triangles has a sum of 180 degrees. So that's great. It works for parallelograms. I had to try it out on an irregular quadrilateral. So this one is totally irregular. It has no sides of equal length. It has no pairs of parallel lines. It has no equal angles. Everything about it is different. But wouldn't you know it, when I cut along a diagonal line between two opposite corners, I end up with two triangles. They are not identical, but that doesn't matter at the end of the day because no matter the shape of the triangle, the sum of all three angles is 180 degrees. So this triangle, the sum of all three angles is 180 degrees. The same thing is true in this triangle. And those two triangles came from one irregular quadrilateral. So I've just proved that the sum of the angles in any quadrilateral equals 360 degrees. And I think that's the one fact that I needed to be able to solve the case of the missing angle.
3 hours later.
All right, so that was brilliant. Like, we worked out so many cool things, and we definitely have the tools that we need to solve this problem now. So this is the problem from the textbook that stumped me before, that like created this whole case of the missing angle. And I know that I can figure it out now because I know that when I take any kind of quadrilateral, including a really irregular one like this, I can prove that it's made up of two triangles. And each triangle I know a fact about. I know that the sum of the angles in every triangle is 180 degrees. So when I put them together, the sum of the angles in a quadrilateral must be 360 degrees. And I tried it with every different kind of quadrilateral to prove that it works, and it even works with irregular quadrilaterals. So let's try it out on this one from the textbook. So I have three angles that I know: 68 degrees, 126 degrees, 106 degrees. And I know that if I were to cut this quadrilateral in half, it would actually be two triangles. So again, 180 plus 180 makes 360. So I know that all of the angles inside this quadrilateral have to add up to 360 degrees. And that is going to give me the information I need to solve this case and figure out what angle S is equal to. So let's work it out. We know that 68 plus 126 plus 106 plus whatever the value of angle S is must equal 360 degrees, because we have proved that all the angles inside a quadrilateral equal 360 degrees. So now I can say, well, what is the sum of the three angles that I know? 68 plus 126 plus 106 is equal to 300, okay? And I did that math and I double checked it and triple checked it, and it's correct. So 300 plus whatever the value of S is must equal 360 degrees. Now I have a problem I can really work out. I can do a couple of different strategies to get the number that S must be, right? I can count on from 300 with numbers that are easy to work with, like 10, 20, 30, and I could go up to 360 and see what I got. For instance, let's say I decided to count on by 20s. So I can go 300, 320, 340, 360. So that's 3 20s, and 3 times 20 makes 60. So that's telling me that the value of S might be 60. There's other ways that I could do it as well. I might just know, because 300 is a nice, really, really round number, and I might just be able to say, well, to go from 300 to 60, it's obviously 60, because 300 and 60. The other thing I can do is I can say 360 minus the sum of the other three angles is definitely going to give me the value of S. So I can do 360, the total value of all four angles inside this quadrilateral. We know that, we've proved it, minus 300, which is the 3 we know, is definitely going to be equal to the value of S. And then we can subtract 360 minus 300, and that tells us that 60 is equal to the value of S. Now, we should always double check just to be sure, especially when we're doing arithmetic like this, adding, subtracting, multiplying, dividing. So the way we can check is we can add up all four angles. So we know for sure 68, and we know for sure 126, and we know for sure 106. And we think 60 is the fourth one. Now, if we put all those numbers into a calculator and add them together, sure enough, we get the total 360. So we did it right. The value of angle S is 60 degrees. We cracked the case. You guys are so helpful. Thank you.